So the vessel was out of class, so it wasn't safe to go to sea, and they sailed it up the coast, out of class. Put it on the hard, got the high pressure water blaster out and blew holes through the hull. So all rotten underneath. So he spent an absolute fortune on this boat, fixing it up. He paid nearly $1 million for it, and then he just spent another 1.5 million on trying to fix it all up. And there was a flash fire, which only damaged a small component of the vessel in a small area, but he tried to have everything below the funnel replaced. So that was the argument I had to get involved in. Yeah, there's a fire on a livestock carrier within the feed silos. So what happens is they load the feed up, and they have anti-static devices on, but sometimes it generates a spark and the feeder will ignite. So they had a silo fire. Silo fires are pretty difficult to control because they've got openings at the bottom. They're not solidly packed, so there's a draft coming up through the bottom of them. They do have firefighting systems on, which is usually a CO2 system for flooding, but they did several things wrong. First of all, they didn't shut the ventilation, the openings at the bottom of the silo, so the draft comes through. So when they did flood it with CO2, it just ran straight out the bottom, so it didn't put out. So then they used all the CO2 up. Then they used the argument that, oh well, the rural fire brigade come in to put it out. So what they did was they sprayed water over the top of the feed, the fodder, which creates a cap which stops the air circulation and controls the fire. So it's more of a smothering operation, and then they started doing it. That takes time. The ship was trying to argue that they said, oh, we should put more CO2 in. Well, they used all the CO2 up for the fighters, and they were going to take it from the engine room flooding system. The two main points that you shouldn't do that is, one, you're going to take away the fire protection for the engine room, which leaves that to a risk of there. The other point is the installations were different, so the bottles wouldn't screw into the other side. So all the action by the fire brigade was good. They followed procedure. It was the actions of the ship that really contributed and continued the fire on. It was a work boat. They just put brand new engines in it. About 6 months before that, they went through and did all the piping system, and they put in some brand new stainless steel sea chests. What happened was these sea chests just for filtering out plastic bags, jellyfish, that sort of thing, stuff going through the cooling system. So what happened was this sea chest failed. So the boat sunk at its berth, and these brand new engines are just totally ruined. So claim goes in. So I've gone down and had a look at it, and I had a look at the sea chest, and what had happened is the sea chest, the bolts they used were a 304 stainless steel. Now 304 stainless steel has corrosion cracking, and what will happen is because they're not a 316 stainless steel, it's not a marine grade, and they have a anodized surface on the surface. So if you break that surface, they will corrode. So what had happened was they put in these 304 stainless steel bolts. It cracked on the thread, lid of the strainer dropped off and flooded the vessel. So I've gone back to the supplier of these components at the local chandlery, and I asked him, so, where's the QA? He said, what do you mean? I said, well, these are 304 stainless steel, that should have been 306. You've purchased them in as fit for purpose, and they're not. And he spun right out and basically hung up on me. So then I reported back to the insurance company that this was the case, and ended up that the insurance company ended up chasing the chandler for the recoup of the funds. It was a bulk carrier, and she was anchored off, and they were going to do some work on the main seawater suction system. They knew the main sea valve was leaking, so what they did, engaged a local company to put a plug into the sea suction on the outboard hull. So they slide it into place, and it's just like a big bellows. You put it up the pipe, and it's meant to sit up against the valve, isolating from the inside. So it creates a seal, and it'll block the water coming out because that valve was particularly leaking. What the shipping company didn't tell the contractor was that they were going to change that valve. So they put the plug in and everything, and then the inboard, the ship's crew pulled the valve out. Because this valve was, the plug was no longer supported anymore, the water pressure was sufficient enough to push the plug straight out. Because they had the valve undone, it just flooded the entire engine room. So it flooded the engine room up to the control room level, which meant that half the engine was flooded. All the bottom plates were all flooded, and it ended up having to be towed back to Singapore for significant repairs. So that was a $5 million claim. Probably the main one I do is design of electrical systems for domestic commercial vessels. Currently I'm doing a hybrid system with a lithium battery bank, 700 volt, 200 kilowatt hour, 2 generators for a feed barge for a fish farm. That's quite complicated, but it is also, I do the run-of-the-mill jobs like simple battery installations for fishing boats. This also includes lithium batteries.